Hi there, this is Neil Bolger with A2 Efficiency, and today we're going to go over how to model VAV terminal unit controls in EnergyPlus and some lessons we learned recently when we were doing some parametric models and trying to get our systems to be controlled correctly. So just as a refresher here, a variable air volume system is a pretty common multi-zone HVAC system in non-residential buildings. This diagram from P&L does a great job of depicting the air handler where you would have a cooling coil and a fan with air then being ducted to these terminal boxes that vary the flow for that zone and also provide a level of heating or reheating at times depending on the conditions in the zone. So the amount of air and the level of heating is controlled by the zone's thermostat, and then all the boxes together send signals back to the air handler and determine what level of cooling is provided and also what level of airflow, right? It's sort of a number of things. We're not really here to talk about the interactions between the air handler and the zone. We're really here to talk today just about like the zone and the flow needs required. All right, so I threw this in here. They had another great diagram that just showed the different damper signals that are here, right? You might have an airflow sensor that's being controlled. You have a hot water coil, like I mentioned, a temperature sensor, all of it with a number of different requirements for how much airflow is required when it's in heating versus cooling versus ventilation minimum versus demand control ventilation minimum. So how did this come up, right? So we were modeling a number of systems and we noticed that in EnergyPlus, every time we modeled our mixed air system, and if we had too low of VAV fractional minimum flow rates, the ventilation air would drop and it would drop below the minimum desired. And we were then modeling a bunch of DOAS units and they were always maintaining fresh air. And it was basically because in EnergyPlus, the DOAS unit had a separate terminal unit just for fresh air and a separate fan cassette or fan coil that was doing heating or cooling. And in the VAV case, they were combined and the box was always dropping. It would like drop below the desired ventilation. And it wouldn't always occur, but just as some examples and numbers, if we think about it, but yeah, this is kind of what we were doing. We were auto sizing the peak flow. We were adjusting minimum flows for VAV boxes. We had our maximum heating or reheat fraction, right? We had this dual maximum control configuration where we said, okay, in heating mode, let's never go above 50% of the peak flow. That's a pretty common control now in VAV, right? They call it dual maximum. And then we had set our ventilation, right? We had our ventilation object, which is a different object in EnergyPlus. And we had defined the minimum ventilation air there that had to be maintained when the building was occupied. But depending on certain situations, right, certain climate zones, the peak cooling would be pretty low. And at certain minimums, the ventilation air, the total minimum airflow was dropping. And so just some examples for you to think about, right? So let's say we auto-sized a room. It had a peak airflow of 600 CFM. And let's say this room had a minimum ventilation of 0.15 CFM a square foot. And we then in EnergyPlus put in a 10% turn down. That would actually be 10% of 600 is 60 CFM and 120. And all of this to say, like, this is really an energy modeling challenge. It's not necessarily a design challenge, right? A designer would know that 120 is the greater of the two and to never let the box go below 120. But just to like try and make sure, especially because in models, very little attention is given to these very small devices in the software, right? We mostly rely on rule sets and algorithms to ensure that every single zone in our 50 zone model is performing how we want, but there's not a lot of time to go and check every single one. We can check the total air and compare that to what we want, though these little problems, if not addressed, can arise. So that's kind of the point of this video, right? So another example, right, if you had a higher ventilation, let's say there was more people in that space, it just exacerbates the problem. Even now at a 20% turn down, again, this VAV box would have a lower turn down than ventilation. Again, if you had, let's say, a room with no windows and the peak load was even less, and you had the same challenge, right now you're almost at like half ventilation, 80 CFM versus 160. And again, not going to occur everywhere, but could occur. And so just like to show again where this plays out in different objects in EnergyPlus, I've highlighted here this single duct VAV reheat air terminal device. And this is a screenshot from EnergyPlus 25. So as versions change, I'm sure there'll be subtleties, but by and large, this object has been around for a long time. We don't really expect it to change anytime soon. But you can see here, this was our zone. We had defined, I'm just showing it's auto-sized. We have this minimum control of 0.3. We had been typing in a number as well that was the ventilation. We had a script, right? So we knew what the ventilation was. And we thought, well, we'll be clever. We'll do both. But it really just ignores this number. It just, because this is set to constant, it uses this constant fraction. And then down here, we had our 0.5 for this dual maximum control. But we basically found that like we were not specifying this linked object, this design specification outdoor air object name. And that was basically the key, right? You needed to say, actually, you terminal unit, you have a sister component that is the ventilation component. And that's really important because that will then override this minimum. It'll kind of solve this problem. If the fraction of the peak that's auto-sized is less than ventilation, it'll look at that ventilation object and pick it up and say, let's not drop below ventilation needs. So pretty critical to get right, especially if you're scripting a model or sort of building this up from scratch. And so just to kind of highlight while we're here, like all these other controls, I think my little arrow is off a little, but so I talked about dual maximum, right? This is a pretty common strategy now. So single maximum would be like where we had this minimum fraction of, this is a diagram depicting like airflow fraction here as a function of heating. You're in the dead band where ventilation is just provided, or just there's no conditioning, and then coolings, right? So classic single maximum, you provide the most airflow when you need the most cooling. And as you can do less cooling, you reduce the flow of air down to a minimum. So we have a single minimum control. So even in heating, you're always at this minimum flow. Dual maximum says, well, let's go further. Let's reduce that minimum even less. Let's not just maybe go to 50%. Let's go down to 20, 10%. And then in heating, let's kick it up. When we're in heating mode, maybe if we need some more heat, when it's really doing a lot of heat, we'll pick that flow back up. So this arrow used to be pointed down here. It's really this reheat fraction. So as long as you put that in this damper heating action control, you basically achieve dual maximum control. So now that allows you that, and the screenshot's not showing the outside air, but right, if we had linked the outside air, we could now set this minimum down to 10%, 0%, and essentially that would allow ventilation to be our minimum, the maximum to work for dual heating. But basically, so that's just like basic dual maximum. But then if you start to look at like guideline 36, a more common standard for what we're calling now advanced VAV controls, there are a lot more airflow requirements that this VAV box needs to be cognizant of as all the different modes are achieved during the year, right? So no longer do we just have this like minimum flow and peak heating flow. We now have perhaps an unoccupied minimum flow, right? So maybe there's a minimum flow that's not zero when it's unoccupied. By and large, a lot of buildings, it's probably going to be zero, but that's in there now, right? Like that's in the guideline, it talks about that. We have our classic minimum, right? It might be ventilation minimum, might be our cooling minimum for control. We then have this demand control ventilation minimum. So if the zone has a CO2 sensor or an occupancy sensor, maybe the ventilation air can now drop to a lower level. If no one's in the room and it's an office and we're using ASHRAE 62.1, that 5 CFM per person might be able to go away, and we just have the ventilation per square foot is our minimum, as an example. Another thing, though, that's really important to think about is this new idea of a heating minimum flow. So when we first start heating, And especially when we're using hydronic heating coils, which is a very common system, especially where we're not using electric reheat, which is most of these systems, there is a minimum amount of flow to get heat to come out of the reheat coil, right? Depending on the amount of rows in that coil, the airflow through the box might actually have to go up from the ventilation level to start to heat. We then still have our peak maximum, and we have still our peak cooling, right? So that would be the size of the box. But a lot more is going on here, right? And so as we think about the logic in Guideline 36, it's great that it's there and it's needed for programming boxes and explaining actual controls to the controls contractor. Though at the same time, we need a methodology to ensure we're modeling it appropriately and we're approximating the energy use appropriately, right? If we have all these resets and we have these modes, unoccupied mode, cooling mode, ventilation only, demand control ventilation only, heating, what's happening? Is the software actually representing the right amount of fan energy and turn down, or is it over predicting energy use or under predicting energy use? So this is just a diagram taken from the guideline that talks about where you might see the change in this airflow fraction depending on the set points for that building. And again, it's a relative chart. There's no numbers, but it is depicting this new sort of jog in the concept, right? We're now lowering the minimum during the dead band. And this might be, right, so going down from cooling minimum, maybe down to ventilation in California. You could imagine if you then had DCV, there would be another number that it drops to when nobody's there, but you're still doing some flow for square footage. Or if it's a space that's allowed to go to zero, maybe it goes to zero. But then, right, the second you come out, you're in heating, boom, you hit this new heating minimum. Well, what's that number? Where are we going to put that into the software? And then you still have your heating maximum. So, right, so there's our heating maximum. So this heating minimum, right, it can change a lot. A lot of this has to do with airflow velocity requirements, again, to maintain stable heat transfer across that coil. It depends on how you're discharging air out of the building. It depends on the type, the manufacturer of the coil. They'll say like, well, to really get heat exchange across this type of coil, you need this much flow. A lot of things that are very driven in the world of picking objects for mechanical design, but things that modelers should be aware of, right? Because that's now a number, right? It might be 30% of the peak flow. Maybe it's 50%. I hope not. That would just mean we're up here again. But even if it's 20%, right? Like 20% might be. So as we look at the EnergyPlus VAV terminal set points, right, and we think about all these different flows, I've done some crazy highlighting on 3 different slides to try and show where in EnergyPlus would you want to make sure we're accounting for all these things, right? So just to start off with here on this slide, we're looking at the terminal unit box. We still got our ventilation minimum, right? That's still kind of defined either by this fraction, 30%, and linking to our outside air object. So if the outside air was our minimum, you could just set this at 0 because we know that would then take over. Heating maximum still there, right? 50%. Cooling maximum still there, auto sizing. We then look at these unoccupied minimum flows and then let's say DCV minimum. So we've kind of jumped over to the ventilation objects. This is the zone's ventilation object. And at that zone, we can sum up the air, which is important because that'll then disassociate these components, floor ventilation from person. We can then assign a schedule. That'll take care of our unoccupied, right? So this is a 1-0 schedule right now, but it could be different. You could have it be a fraction. So you'd have some outside air at night if you wanted to. But that's basically how you would control for that. And then DCV, the way they recommend doing this is actually to add this contaminant controller. So every zone would now actually get a schedule that defines its desired CO2 limit. And people in EnergyPlus actually emit CO2. So since people have a fractional schedule tied to them, that schedule then emits a variable amount of CO2. And as that collects in the room, and if it hits a certain set point in parts per million that you can define in a schedule, it would vary the flow of air. So effectively, that's a contaminant mechanism way to adjust this person flow. And then to get any of this to work at the system level, you have to tell the controller, hey, I have DCV. That has to be enabled. Hit yes. And then heating, right? So this is where it becomes pretty tricky, right? So right now, there really is no airflow input for a minimum heating flow. And maybe it's not needed, like argue it against me, feel free, throw a comment in here. But essentially, the way we've thought about this is like, okay, well, if there was a need for a minimum flow, I think I would end up writing an energy management script that would have basically look at that zone, add a little EMS script anytime I add a zone that would say like during runtime, if there's a heating request in that zone, override this number to be 0.2 or 0.3 or whatever it is. And you could even change it to be a schedule that's a bunch of 0.3s, or because it's a lot easier to write an EMS script that overrides a schedule value than the hard set point. So you could do a little bit of work there, but that's a lot to add, right? Like not everyone knows how to add an EMS script and add a variable that's actively watching that zone. And then also do that for every single zone. In the age of scripting, sure, maybe people are building models more in templates, but it's no small feat to add for sure. And it actually makes us kind of think about like, are VAV boxes actually the same as variable flow chilled beams, right? Like we model variable flow chilled beams. We actually had a project. It wasn't even a modeling project. It was a field assessment project. We were evaluating a school that had a bunch of variable flow chilled beams. And the way they worked is when they were in the dead band, no heating or cooling, it would drop to ventilation. And it was great. And it was actually more static. This line was like lower down here, right? It was in ventilation, but the second it went into cooling or heating, it would jump. It would basically go from, let's say ventilation was 0.2 CFM a square foot, it would jump to 0.3 at the smallest inclination of cooling or heating. And so we ended up modeling that, right? We ended up saying like, look, you're actually going to have more outside air. It's still variable, so it's better than a constant flow induced chilled beam, but it basically had this mechanism, right? It would go up to some high level of heating to induce enough air to create that Coanda effect across the chilled beam, and then again, more airflow for cooling. And this is even in some of the manufacturer's literature later, which demonstrated like, sure enough, cooling was about twice heating. So I think that slide should have been deleted, but basically, right. So these are our recommendations, right? If you're gonna model this in EnergyPlus, ensure you get that outside air object length. That's key. Get your heating maximum set, almost a no-brainer, dual maximum. And then at the minimum, if you're not gonna go around this like and add this EMS script, I would at least consider looking at like, what's that minimum flow we need to get enough airflow across the heating coil? Is it 20%? Is it 10%? Because you really should be using that number, even if at times the whole system can go to ventilation only. Because a lot of the time, it's gonna do a little bit of heat. And just to note, like even in CBECC Title 24 compliance software, there is no heating input, right? It kind of makes sense because it's not an EnergyPlus, so it wouldn't be readily available for them to add. But essentially, right, this means like if you were to model this now where your minimum airflow is ventilation, you're probably going to underpredict fan energy use by some amount. Because if you actually did have a building that needed a little higher flow to achieve a small level of heating, you're going to see the fans run more often. So just a way that we could be cognizant of where might a model deviate from reality. Anyways, that's all for me today. Catch us more for more things like this at a2efficiency.com or follow us, send us an email if you want to follow us or have any questions.